Hello everybody, and welcome to another video on implicit derivatives. Well, I grabbed the textbook this time via Cengage, and right here we have this following question, number 42. Find the equation of the line tangent to this curve at this point. Alright, so how does one find the equation of a tangent line? Well, remember, the equation of any line is y equals mx plus b. All right, so that's the equation of any line. What makes it a tangent line? Well, that slope is going to be very particular if we're looking at a tangent line. The slope of a tangent line is dy dx. That is, you guessed it, the good old derivative. So in this case, the first thing I gotta do is find dy dx. That's the very first thing I gotta do, is find dy dx. So how do I do that? Well, I look at my equation over here. My equation is actually two product rules, because when you have anything in front of a log that's not a constant, so a variable in front of a log, you got to do a product rule. When you have two variables back to back, it is a product rule. So I'm going to be doing two product rules here. So I got my first product rule, plus I have another product rule. And then on the other side, it's easy, right? Because the derivative of the left-hand side is a product rule. That'll be this piece. The derivative of this will be a product rule. That'll be this piece. And then, where are we? The derivative of 2 is easy. That is 0. So we know this equation is equal to 0. So we just have to go through the product rule. So we need the product rule for x log y. Let's just focus on that piece. The derivative of x log y. Well, here we go. My u is x. The derivative of x is 1. Leave natural log alone, because that's the product rule. U prime v. Now, it is u, so leave the x alone, and then take the derivative of the natural log of y. Well, the derivative of the natural log of y, the derivative of the natural log, is 1 over the inside of the log times the derivative of the inside of the log, because the log derivative is a chain rule. So the derivative of a log itself is 1 over the inside of the log times the derivative of the inside. Well, the derivative of y should be 1, but remember from our previous lecture, if it is the top variable, that really stands for the function, and we don't know what the function is, so we have to write y prime, or you could write dy dx there to be fine. All right, on to the second product rule. In my second product rule, my u is 2x. The derivative of 2x is 2. Leave the y alone. I imagine a dot between the 2x and y. That's why I know it's my product rule. That's why I know my u is 2x and my v is y. So for my product rule, what I have, derivative of the first piece is 2. Leave the second piece alone. Now I write the second piece. The derivative of y, here we go again. The derivative of y should be 1. But y is a more complicated function, so I have to write by the chain rule y prime. And so this whole long expression is the left-hand side. Two product rules. Please, now that we've written down, let's talk about this one more time. When you have a variable in front of a log, it is a product rule. If you have two variables back to back, it is a product rule. That's really why I'm doing this, to really highlight when you do the product rule. Now let's simplify. 1 times log of y is just log of y. What's next? X times 1 over y is really x over y, because that's how you multiply. So that's x over y times y prime. Again, x times 1 over y, you multiply numerator, denominator, and that's how I got that expression. And that should be a times there. All right, 2 times y is 2y. And then 2 times x times 1y prime, you smush it together, and you get 2xy prime. And that equals, sorry for crunching this in there, 0. So I'm going to imagine that's equal to 0 because it's hard for me to write on the edge of the screen. Actually, if I do this, I can get my 0. Okay, so as previous to the other, and in fact, I got some space here. Let me clean this up for you. That should be a 2y right there, and that's my expression. So what do I do next? Well, now I got to get the y primes by themselves. It's all about algebra. It's all about solving for y prime. Because remember what we're trying to do in step 1. Find dy dx. That is better known as y prime. So let's find it. How do we solve for y prime? Well, what you need to do is if a piece does not have a y prime, like those two pieces, move them to the right-hand side. I always do the same logical steps. I get everything with a y prime on the left, anything that doesn't have a y prime to the right. So I'm going to keep, let me change that back to a pen. I'm going to keep x over y times y prime plus 2xy prime on the left. The right-hand side, I got to move the natural log. That is a subtraction when you move it across. So that's minus natural log. I'm going to move the 2y, so that's a minus 2y when you move it across. Good algebra skills. Now, second step of the algebra. These are always the same steps when you do this. First step, move the y primes, or actually I'm going to keep the y primes on the same side. Move the non-y prime items to the right by adding or subtraction. That's all you would do. How do you know when it has a y prime? It'll be multiplied by y prime up here when you did the derivative. Now, everything that's on one of the sides, in my case the left, should have a y prime in it, and they both do. They both have a y prime. That means I can factor out the y prime. So I factor out the y prime. And I get the following expression. Imagine distributing the y prime back through. Y prime times x over y is that. Y prime times 2x is that. The right-hand side stays the same. And that's my expression. All right, last step. The good news, it's always the same 3 algebra steps. Move all the y primes to one side, everything else to the other. Now that all the y primes are together, factor out a y prime, always that step. And then the last step you always do is divide over that parentheses. That's the last step you need to do to solve this expression for dy dx. And honestly, I just read it as x over y plus 2x. And so there is my y prime. Really nasty. Negative natural log of y minus 2y denominator x over y plus 2x. The good news, that is dy dx. The good news, we're at a particular point in this question. Because remember what we're trying to do. We're trying to find the equation of a tangent line. The equation of a tangent line has a very particular slope. A tangent line slope is the derivative at that point. Let me go back to that question. The point in question, what was our point? Our point was 1, 1 for this question. Got to make sure I get the right point. So now we plug in 1, 1. So let's do that. We're going to plug in 1, 1. So it'll be natural log of 1 minus 2 times 1. That's the y is 1, so I'm plugging in 1 for y. Good news, by your calculator, you'll notice the natural log of 1 is 0. So really, you just have a negative 2 in the top. So my m, my slope, is going to be negative 2 over, let's get my denominator. So it's 1 over 1, because that's both x and y, 1 over 1 plus 2 times 1. Again, imagine plugging 1 in for x and y everywhere. And so you get 1 over 1, that's 1, plus 2, so that's 3. So there's my slope, negative 2/3. Now that we have the slope, we move on to the second step of the equation of a tangent line. We know, so far, the equation of the tangent line is y equals negative 2/3 x plus b. Now we need to find b. To find b, we normally need a point. Well, the good news, they gave us to us, right? They gave us the point 1, 1 to use. So I'm now going to plug 1, 1 in for x and y and solve for b. So when I plug in 1 for y and 1 for x, I get this following equation to solve. How do I solve it? Well, you would multiply and add over to 2/3, right? That's really what you're going to be doing, is adding 2/3 to both sides. Good thing there's an eraser. Now we're good. Plus 2/3. There we go. And so what we see is b is equal to, well, 1 plus 2/3. If you're bad with fractions, you got the calculator. That looks like 5/3 to me. 1 plus 2/3 looks like 5/3. So finally, I have my answer. My answer is, my tangent line is y equals, my slope is negative 2/3, negative 2/3 x plus 5/3. And that will be the equation of the tangent line to this curve at the particular point 1, 1. Please stay tuned for another video on implicit derivatives. Thank you.